simplifying algebraic fraction. They're actually super simple. This one looks quite intimidating, but there's a cool trick you can employ here. So you want to stay tuned for part D. So to simplify algebraic fractions is very simple. We just need to rewrite everything as multiplication. Because when we have fractions, if I have something like xy divided by xz, the x's cancel here. However, if I write this, x plus y over x plus z, the x's do not cancel. Let me give you guys another example with real numbers to help you understand. So we have 2 quarters. Okay? I can rewrite 2 as 2 times 1. And I can rewrite 4 as 2 times 2. Aha! I've written it as multiplication. The 2's cancel. I'm left with 1/2. However, if I rewrite 2 as 1 plus 1 and 4 as 1 plus 3, are you allowed to just cancel out the 1's? No, because that would say 1/3, which we know is not the same as 2 quarters. So, plus, no good. Multiplication, tick. Okay, so let's go ahead and rewrite everything as multiplication. Now, when we have quadratics, how do you rewrite things as multiplication? That's to factorize. Because here, you can see there's minus, minus, plus. It's not looking good. We need to factorize. On the numerator, it's actually a really easy one. We can just take out an x. Okay? X is common in both of these terms. X times what gives you x squared? That's just x. Minus, when you factorize out an x, you're just left with 4. Over. Now, I already know that x minus 4 is going to be in the denominator. That's part of my trick for part D. But anyway, let's think about this. What multiplies to give you 8? Well, I already know I'm going to use the 4 one. So 4 and 2. How do you make minus 6? If you have minus 4, minus 2. Now you can see the minus 4 on the top and the bottom. You can just cross them out. X minus 4 divided by x minus 4 is 1. So x over x minus 2 is your solution. All right, part B. Here we just need to know how to factorize both of these. There's no common factors anywhere. So here, obviously for all of them, we have x, 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 x. Now for 12, what are my options? I have 1, 12, 2, 6, 3, 4. Which one of those options are going to help me work out? I'll just write them. Which one of those are going to allow me to make 4? Well, that's going to be 2 and 6. How do you make plus 4? 6 minus 2. For 18, what are my options? 1 and 18, 2 and 9, 3 and 6, and that's it. Which one's going to help me work out, get a plus 9, 3 and 6? As long as they're both positive. And there you go. You can see how they cancel out. So the x plus 6 goes now, and we're left with x minus 2 over x plus 3. Part C. 6x minus 9 over 4x squared minus 9. Now forget about this for a second. When it comes to this, students are so focused on factorizing double brackets, factorizing out an x, they forget that they can factorize out numbers as well. What goes into both 6 and 9? It's 3. How many 3's go into 6? It is 2. X minus 3 goes into 9 3 times. And the denominator, dots. Difference of 2 squares. My students always troll me. Every time I write dots, or how do you factorize this? They literally just put this in the chat, and they just spam it. And yeah, they got me real good the first time they did that. I didn't understand what they were doing. They're getting too smart for their own good, these Peppa Pig watchers. So, difference of 2 square numbers. What multiplies by itself to give you 4x squared? 2x. 2x times 2x is 4x squared. What multiplies by itself to give you 9? 3. The difference of two squares principle says that one needs to be plus, one needs to be minus. Because there's no x term. So they need to be the same. One needs to be plus or minus so that they cancel to give you 0. Okay? Because this will be minus 6x plus 6x. They cancel to give you 0. And then we see the answer. These cancel. 3 over 2x plus 3 is your solution. Finally, part D. We need to factorize. Forget about the numerator for a second. Yes, you could use the best method ever invented, being the oi oi method, or we can just be smart about this. I know how to factorize the denominator. Again, that's difference of two squares. What multiplies by itself to give you x squared is x. What multiplies to give 1 is 1. 1 is plus, 1 is minus. I immediately know that one of these terms is going to cancel in the numerator. So I already know what's going on here. 3x squared is 3x and x. And this is why questions like this, AC methods really struggle, because they can't do this concept of being able to just see the bracket. So I already know with the cancellation that this is going to have to be 1. 1 times what is 4 is 4. Now we do oi oi. 3x times 1 is 3x. This gives me 4x. 3x and 4x, how does that make minus 7x as if they're both minus? So there you go, both minus. And there you go. I didn't even need to factorize it. The denominator just did it for me. 3x minus 4 divided by x plus 1. And that is it. So guys, if you still need practice with the oi oi method, I have a video on it already. So go ahead and check it out. But if you did learn something today, I'd appreciate if you hit the like button, subscribe for more maths content, and if you're interested in my GCSE courses, more details in the description, and head to the Lung Gang Reddit page if you want to submit your own questions and get feedback from the community. Link to that is also in the description. I'll see you in the next video. Nice.